Hi, everybody. Welcome to today's webinar. We are going to be doing a sneak peek of the exciting optimization tools and workflow improvements that are coming in version 11. So if you haven't joined us for a webinar before, my name is Erin. I'm the Business Development Manager here at Softree. And with me is my colleague and our resident webinar presenter, Matthew Dickey. He will be handling, I should say, the lion's share of today's presentation. But to start, I'd like to give you a little bit of housekeeping, as well as an introduction to some of the exciting new functions and features and workflow improvements that we've got coming in version 11 of Softree Optimal. And that's scheduled for release in February 2024. And I should say 2 of these features are available in I'm going to say our core RoadEng projects. So these functions today that we're going to talk about. So we've got Path Explorer. It's a new AI-based tool that can help you determine the best road location from point A to point B. We've got our completely redone hydrology toolkit, and that is a regular RoadEng feature. We've got Polyline to alignment, and we have smart curves. So I'm really excited to share these features with you. And just a little bit of housekeeping to start. First off, you are muted, but we would love to hear your questions. So we encourage you to engage with us throughout the webinar. You can type your questions into the GoToWebinar panel. If you expand it, there's a little section for questions. Type them in. Question askers do remain anonymous, and we will address those at the end of the presentation. So to get started, let's talk a little bit about what a greenfield road design workflow with our optimization tools now looks like inside of RoadEng. So you start by importing your data. This is high resolution data like LiDAR or drone data. We create our tin surface, and then we're going and trying to determine the best road location, either manually or out in the field. So we've got techniques like road pegging you can use. Maybe you've got a preliminary alignment that you've kind of figured out in GIS. So you're determining that best road location. From there, you're creating your horizontal alignments through a relatively manual process. You're clicking in IPs, you're applying curves, and then you're leveraging the power of our Optimal software to optimize that vertical profile, to reduce your earthwork construction costs, to minimize the cuts and fills and the movement. So that's a really, powerful step in the process now. But what we're finding is that sometimes you're having to adjust your curves to be more constructible. So in minimizing our earthworks, we end up sometimes with a lot of sort of a wavier alignment, something that's got more curves, they're back to back. And so although it's minimizing those earthwork costs, you're having to make adjustments to make it more constructible. And that kind of brings me to the exciting part of the workflow changes that we have. So we have a whole bunch of opportunities within this workflow to make it a little bit better. So we're going to just scratch out a few of those workflow steps, and we're going to insert some new tools to drive efficiency and some improvements. So to start, instead of trying to manually determine the best location for your road, you can leverage Path Explorer. So Path Explorer, we'll talk about it in a little bit more detail on the next slide, but Path Explorer is going to allow you to say your point A, your point B, so where you're starting and where you're ending, as well as a whole bunch of different input parameters, construction zones, costs, etc. And it helps you to identify those best road locations at the high level, sort of within our terrain module. And here you can leverage our new hydrology toolkit as well. Next, instead of creating your horizontal alignments manually, we've got Polyline to alignment. So an exciting tool that can take any type of polyline and convert it to a horizontal alignment with curves. And then finally, making our vertical optimization software really start to make a lot more sense and to be a lot more ready for the real world and being constructible. We've got smart curves. So let's take a brief minute, and I'm going totally over time based on not having my slideshow properly. Let's take a brief moment and just talk about what each of these sort of looks like, and then I'll be passing it to my colleague Matt to go into a lot more detail inside the actual software. So as I said before, we're finding our roads kind of manually, and now we're moving into this sort of more, generative space using some, basic I'm going to call it a basic AI tool. So Path Explorer is quickly finding those optimized routes between point A and point B. It considers road-specific constraints. So it's looking at your road width, it's looking at your side slopes, it's looking at your minimum cut, maximum fill, your curve radius, and it's doing this and generating alignment options for you that are looking to optimize the earthwork. So our servicing costs and our earthwork costs. And it's doing this within minutes. So it's a really, really exciting tool. We are, so excited to share it with you, sort of in the most, our official presentation of it today. And you're also, with it, able to leverage the hydrology tools that we're adding in version 11. So we look forward to showing you those as well. The next sort of workflow improvement that I had mentioned was this idea of going from this sort of creation of a horizontal alignment manually now to using something that's much more automated with the computer. So Polyline to alignment takes any type of polyline. That could be a shape file. It could be a P-line traverse for those of you in the forestry sector. Or in this case, I've got up here one of our XPaths that comes out of Path Explorer, and it takes this and it converts it into a proper alignment with horizontal curves applied that meet the minimum curve radius that you need. And it does so, again, this is minutes. So huge efficiency savings when it comes to creating horizontal alignments. And then finally, in terms of making our vertical optimization tool just so much more effective and real world applicable, we can use smart curves. And so smart curves, it really improves vertical alignment optimization by identifying and reducing the number of unnecessary curves, back-to-back curves, and combining curves as well. And the end result here, as you can see, is just a much more smoother constructible profile, but most importantly, one that is still optimized for earthworks. Okay, I'm sorry for running a bit over, Matt. Hopefully you can make up for it. But I'm going to pass it over to my colleague, Matt, now. And I'd really just like to, thank all of you for being here today with us for our last webinar of 2023. It is an absolute pleasure to create and to host these webinars. And I really hope that you guys enjoy this one in particular as much as we did creating the content for it. So Matt, over to you.
All right, perfect. I'll turn my camera on to say hi, but of course I'm going to be looking at a different monitor. So I will turn my camera back off, and we'll dive into an example and kind of look at how this new functionality works in a few different examples here. So we're going to start by looking at a project that's largely already set up. So I'll just kind of see our plan view. I've got some areas delineated where I don't want to go. And then I've got my streams already created, and I've got this line here, and all it is a start point and an end point, and we're going to let the software figure out a way to get from there all the way to over here. So like I said, a lot of this is already set up. I'll go into it right from square one in a moment, but we'll hit OK and let the computer think for a bit. So it's not instantaneous. It's probably going to take a couple minutes for this one. But yeah, the software right now, it hasn't found a solution yet. We can see that in the dialog that's keeping track of our elapsed time. But that will change once we've found a solution. And one of the options that I had set when I hit run was that it would find, I believe we're looking for five decent alignments to investigate further. So it'll first find one, then it'll find five, and then it'll continue to search until it recognizes that, well, it's probably not going to find anything better. And then once that happens, we'll hit cancel and see what it spits out. So let's let this thing run.
The joys of live webinars. You unfortunately have to actually wait while our software solves.
And we'll make you wait for a couple times. The last example, we after we've made you wait a couple times, will be pre-recorded. That way we can speed this stuff up. But yeah, I suspect it'll probably be around the 2-minute mark. Running it without a screen sharing program also running, it was around a minute. So and of course I would offer to answer questions, but we aren't really that far into it to generate questions. All right, so now it says it's found 5 paths, so it's going to continue searching here for a little while. Yeah, so that it'll, I don't know, maybe take another minute. So it's longer than I expected it to be. But yeah, it's if we consider the scale of things and the terrain that we're dealing with, we're looking for a 50-kilometer-an-hour road with a straight line distance of almost 4 kilometers. And of course, we told it we can't go the straightest route. So it's a fairly tricky problem.
And this tool is quite memory intensive, although we've got caps on it to prevent it from crashing your computer. But the larger and the more powerful computer you have, the faster this potentially can solve.
So it says unlikely to improve further. I'll hit cancel. And then we'll hit OK. And it's going to take well, it's probably going to take another minute here to do some post-processing. And once that's done, we'll be able to see where the software suggests we put things. And then I'll back up. We'll go to a entirely fresh project and look at it with setting up all the nitty-gritty and then taking it over in location.
So while we're letting this post-process, we do have one question that's come in that I think feels really reasonable to answer here, which is, what is the recommendation for a CPU and graphics card for this update?
And I'm stumped. I don't know the actual answer for that. I can tell you what I'm running. My computer, I think, is a few years old. It's got an i7 processor and 16 gigs of RAM. So the bigger the problem, the more computing power you'd like, but it's also something that you can chunk up into smaller problems if you're kind of limited for the computing power that you have. Do we have a firm recommendation on where we put things? Erin?
I'm just actually checking with our development team as we speak. I was not prepared to answer that question, but you've got some results, so why don't we pause it and we'll come back to that question. It's a great one.
So we've got our solution. It's coming across the top here and crossing our streams and getting to that final point. So we're going to jump out of this one, and then we are going to deal with something a little less intuitive and build it right from scratch. So blank terrain file all the way to the final alignment. So some of this will be very familiar to those of you that are already familiar with our software. So I'm going to start a new terrain file. I'm going to click Insert File, and I'm going to grab my LAZ files here. Yeah, standard stuff, my projection set. We're going to bring in those tiles. And so there's our point cloud being brought in. Click off to the side, they're deselected. I'm going to click terrain modeling, generate. and we'll generate our surface here, and we'll also do contours at the same time.
And for those of you who just joined us, we are stepping through a workflow to showcase some of the new optimization tools. I saw, yeah, quite a large jump in attendees. So welcome. And Matt's just going through an example.
Perfect. Yeah, so we've got some pretty humpy bumpy terrain. This example is in the tropics. So that's, well, at a glance, that's what we're up against. And so with this, rather than just arbitrarily picking a point, I'm going to insert a shapefile. So this shapefile has 2 points. I'm going to change my symbols so they're a little easier to see. So there we are. We want to go from there up to here. So we could join them, or we can just create a new feature here. And we want to go from that to here. And we're going to look at our 3D for a moment. I'm going to just change this color to be a little easier on the eyes, make it a little transparent. And I also don't want to see all those contours, so I'm going to just hide my contours. And this isn't related to the kind of core workflow. This is just making it a little easier to see what's going on for those that like to see it a little easier. So we've got that. If we just tell the software to go from here to there and only consider earthworks, well, we've got a lot of small valleys and low points. We should probably consider water. So I'm going to click Train Modeling. I'm going to go over here, and we're going to run the streams and ponds functionality. So this has been completely revamped and improved upon. So we're going to automatically generate a bunch of vectors that represent our streams, and we're going to generate a bunch of polygons that represent areas where we expect it to pond. This is a raster-based calculation, so we are simplifying the surface down into a series of cells, and we're going to generate streams wherever we have flows that accumulate with an area greater than 10,000 square meters in this case. So we'll hit OK. So there's our streams and ponds, which makes sense. All those channels have water in the bottom of them. So let's make it so we can see that point A to point B line. And we are going to first set up our construction zones. So that's where we're going to account for anything that deviates from our default values. And we can even set our default values here. So I'm going to start by changing my unit rates for dollars per cubic meter for excavation costs. This example I want to run with a 12% max grade. And then we're going to click New. And I'm going to add in, well, not no-go polygons, because in this case, those ponds, there's some that I'm probably going to inevitably want to cross, and I'm going to just make them more expensive. So I'm selecting the pond features. And I'm going to say, well, let's just go with a big number, not worried about getting something that's perfect here. We just want it to act as a a bit of a deterrent. And then for those streams, I will choose something that's reasonable. So we'll go. So I just, rather than manually selecting these, I use the select based off text. And I'm going to say, well, typically it's going to cost $5,000 for each one of these crossings. So again, we could strip that down into whatever level detail we'd like for individual streams or individual reaches of streams, but we're going to keep it pretty simple. So we've got our construction zone set. We're going to go over to the Path Explorer tool. I've got my minimum radius set. I'm telling it that I want it to produce 5 options. These parameters are being brought in because I already set my defaults in the other portion of the UI, and we're going to set a minimum or a resolution of 8.75. So rule of thumb, we like to keep that no greater than a quarter of your radius. So we are going to hit OK, and once again, folks are going to have to wait, and we'll let this snake around through the topography and find us 5 options, 5 options that are cheap. So with this, once again, it's going to run for a bit, and I thought it was oh, go ahead.
Well, I was going to say, we're going to take an opportunity to answer a couple of these questions. Okay. So one of them, and this one's quite relevant to the dialog box, you had previously had open maps from Path Explorer, which is, what is resolution?
Resolution, so it's, I guess it's a pretty big problem to solve, and we want to capture what's important, but we also want to keep it fairly simple and fast. So some things we're approximating. So with that, the resolution, we're not looking at the same level of detail as the surface that you and I are looking at right now, and there's some approximations in there that could lead to deviations of up to whatever your resolution is. So if you have a no-go area that is, say, within, well, in my case, 8.75 meters of my start, well, it might think that your start is in a no-go area. So a little, yeah, it's just reflecting that there are some approximations in the what we're considering. And the smaller the number, the less approximations, but the longer it'll take to run.
Awesome. And with that, I also have the answer to the previous question that was asked about the computer specifications that were needed for this new update. So that being said, with Path Explorer, it is specifically a 64 and version 11 in general. It's exclusive now to 64-bit computers. There are no requirements on the graphics card, so an integrated graphics is totally fine. A CPU as well, doesn't matter. The big piece is really the RAM. So our recommended memory is 8 gigs of RAM. And that's, again, minimum recommendation is 8 gigs. Obviously, less is doable and usable. However, it may just limit your ability to run larger problems. So yeah, hopefully that helps with that one. Matt, would you like one more question while we wait?
Oh, it says unlikely to improve
never
further,
mind.
so I'm going to hit
Too
cancel.
fast for us.
Oh, actually, it's going to take probably a moment here. So if it's a quick question, we can answer.
This question is about full, and there's so many questions, so I'm trying my best to get through them all. Full bench requirements and steep slopes. Can it account for them?
Well, you can apply it in the vertical optimization side of things. And I mentioned in the question about resolution that there are some things approximated. So there's not a full bench button, but you're also using a simplified cross section when the software is calculating this. So without even without having a button that applies a full bench constraint, it's still going to avoid those steep areas. And there is a simplified cross section in the model when it's considering things. So it's going to deter. It's not going to want to go places where you've got these long runaway fills that are associated with where that prescription gets applied. Yeah, hopefully that answers it, and you'll notice that if even without applying it, it gives pretty reasonable results. And then when we get into the vertical optimization side of things, we can nail that down and further refine it. Hopefully that answered the question. Now this has run. We've got our solutions. So we can see some are going off to the side here. They look fairly reasonable. So with that, if they weren't reasonable, I'd say, well, I don't want to go over there because, and I delete it and I wouldn't even consider it. But where these look fairly good without me not accounting for something, I'll go up here and I'll say, well, let's look at that one. So this number that comes afterwards is the expected cost based off those parameters that we've put in there. So this solution here that snakes around and comes up that ridge is expected to be the cheapest one. But this is kind of a front end tool. We're certainly going to look for a more refined solution as we switch over from this, where we just see it as a line, and we'll look at it in location. So here I'm going to hit File, Save As. We're going to save it as topo. All right. So we've got that saved. I'm going to switch gears over to location.
And for those of you new to our software, RoadEng is modular. So we've got the terrain module, the location module, and then there's this add-on called Softree Optimal that exists now within both modules. Not to, make it confusing or anything.
All right, so I'm starting a location file to start just the same way as I normally would. And let's go up here. We're going to grab that topo file that we've just saved. And here, I'm going to use one of those alignments that we've created. So I could select multiple if I'd like. I'm going to just run with a single option here to start. Oh, and I'm going to and so it's calculating just the initial alignment. And here we are. So we've got an alignment in there. And just to start, we can see, well, there are an awful lot of points in here. So we're going to reduce that. We're going to, rather than just tracing it in or deleting a bunch of points by hand, we're going to use our new Polyline Do Alignment with Curves tool. I'm going to set that to be that, and that to be, oops, that. We'll hit OK. And so once again, something that isn't instantaneous, but if you consider the scale of what we're doing, it's still pretty quick. It's going to remove bunch of IPs and break it down into curves and tangents. So the settings that I set there included the minimum curve length and a tolerance to allow some deviation from the original line. So we've got that. And we will continue right along. So right now we've got a line that is draped on our surface, and we're going to use our vertical optimization tool to further refine this. And this is going to consider more details than what we considered with the Path Explorer tool. So for starters, Path Explorer tool had a simplified cross-section assumed. This is going to consider whatever cross-section we have applied. I'm just going to run with my default, but we could change that to be whatever we'd like it to be. It's going to consider the ground types and the unit rates that we have here. And I'll run with something different than I did last time, but the big thing here is the Path Explorer wasn't accounting for my material movement. So this is going to account for my material movement. And let's configure this. So vertical options, we're going to set our spacing, sampling along our alignment. We're going to set our grade constraints. And I'll come over here. I'm going to click control point. So I want to start my alignment at ground, not in a cut or a fill. So I'm going to add a control point where I want that to be at a certain elevation. And we could go through and add more things, but I think this is going to give you reasonable results just to start. And then here we are with something else that is new for version 11, and that's the smart curves. So I'm going to leave this on. We're going to hit process. It's going to take a bit to go through and sample and solve for where things should be. And then we're going to have a vertical to accompany this great horizontal that we generated. And while it does that, I'll just mention too, this is you're not stuck with any of it. So it's still just an alignment and location the way it's always been. So if you want to move stuff around after the fact, feel free. It's yeah, we're showing it as a continuous workflow, but you can absolutely explore and tweak things anywhere along the way to meet your needs. And we've probably got another bit of time here for a few questions.
Definitely. So a lot of these questions are focused back on that Path Explorer step. So
Okay.
kind of building on the full bench question, can you apply higher construction costs based on side slope to influence Path Explorer?
Yes. So there is nuanced answers to that again. Since we're using and I'll just come back here for a sec. And let's see if I can pop up the help files for this. So I mentioned we're using a simplified cross-section. So with that, one advantage is if it's just a matter of how much dirt you're moving, the fact that we're using a cross-section, the steeper it is, the more dirt you're going to have to move. So there should be an increase in cost there right away without increasing the unit rates. Now with that, there's other aspects of things. So if you have a different material that's common on your overly steep terrain, you can delineate that as a construction zone and add in additional costs for polygons that can have a different excavation or fill cost associated with them. So that's the manual approach. And I switched over to my to be in beta mode, not the alpha mode that we use internally. And there's some stuff in the works to do more kind of automated surface functionality for costs as well. So that is probably going to include more of a direct yes than the two kind of supporting functionalities that I just mentioned. And I heard a chime. So we've got this, it's telling us that it's found a solution. And there we are. So we've got a solution. And of course, it's vertical optimization. So I'm going to just focus on the vertical, but I mean, it's still a 3D alignment. So we can look at the 3D, but here we are, and we can see that, well, we're coming up. We've got our cuts and fills balanced. We're not maxing out our grade, but we're close. So in the previous versions, without that smart curve setting, this would probably be represented as a series of very small curves. And now we've got something that's much more simplified, and same with out here. Now, the nice thing about this function is it's fairly smart. So if you have all stuff like this, where the cheapest solution is to knock out those humps and get rid of it with what fits there, it's going to still contour around the major curves to give you the cheapest solution. And then down here, we can see that total cost based off of our unit rates and movement cost here is being tabulated for here. So that's kind of the gist of the new optimization functionality. Beyond this, it's the same workflow that all of our non-optimizer users are familiar with. We can add in our culverts where we want to drop a pipe and continue on to produce our documentation and staking information. So with that, we've got one more example, and we've made you wait enough. This one is pre-recorded, so we won't watch the computer think. We've got it set up to start without any construction zones. This is a steep example. We're going to leave the max grade at 18%, minimum curvature of 20 meters. And here, this is a fairly big, hard to solve problem, so it took a little longer. It's sped up, but it takes a little over 4 minutes to actually narrow in on the best solution. And then here, it looks like we didn't speed up the post-processing for this part, so do get to watch it for a minute. But here it's going to produce something reasonably quick. And there we are. Now with this, well, some of you will probably see it right away, but if we zoom in, it'll become even more apparent. There is some really nasty terrain there. Kind of a terrain stability nightmare with all sorts of scarps and old slides and sloughs and whatnot. So where it's initially suggested is not really an option. So we're going to add in some polygons, and we're going to use those polygons to act as a deterrent. And with that, so if we delineate all of the areas we don't want to be, something that when I ran this, I wasn't sure if there was actually a feasible solution to avoid all of them. So we could have used those as no-go areas where it would have been a firm, the alignment's not allowed to go within those polygons. But we can also just put in a really big cost. So that is kind of a soft constraint where, well, it's going to be so expensive that it's going to really not want to go there. But if it has to go there, if it means that we can get there or not, well, maybe we can figure out some kind of special prescription to build through it. So yeah, throwing in some big numbers. Now this one also didn't account for the cost of streams originally, so we're going to add in Polyline with the crossing cost, just the same as we did with the previous example. And go with a 2,000 kind of minor crossing cost. And we're going to rerun. So just take note where things are at to begin with. So we've got a solution, and with this, rather than going all the way to the ridge on the right where it originally was, it's switching beforehand, snaking up between those two polygons there. And then we've got a few options that are really threading the needle to get around where we'd like to be. So here's a case of, well, maybe we don't go strictly off cost. Maybe we look at it in terms of, well, I'm really close to this polygon that maybe I should have been a little bit bigger with. And we can, just as much as we evaluate it quantifiably with the costs, we can also do that kind of litmus test and judgment of, oh, well, I don't like this one. It's still a little too close to that headscarf. So with that, we've got our three Path Explorer examples, and
Oops. Yeah, we'll handle some questions, and I think I'm comfy staying a little bit longer because there are so many here. So to start, we're going to go way back to the beginning, Matt, and there was a question about your tin that you had in your very first example. So in that, they're wondering what your underlying tin was built from, and how it was inserted into the terrain file.
Okay, that underlying tin in the first one was a DEM, but it's kind of all the same. The second example that we looked at was LAS or LAZ data. Yeah, could have been photogrammetry data, could have been total station data or something like that if you had the ambition to survey a big area with all of your potential routes. And it doesn't necessarily even have to be high resolution information to start. You could use whatever's available. Could be low res DEM, could be a surface generated from contours, etc. So hopefully that answers the question, but the gist of it is the functionality is independent of the source of the data.
For the new hydrology tool, next question here, which is how do you know what area to use in the parameters to define the hydrology outputs?
Yeah, let's go over to that. So that area will vary a little bit depending on location. Yeah, so as you're getting your feet under you, the best way is to kind of try it iteratively. It runs pretty quick, and do that sanity check of, okay, that makes sense that in this case our streams are crossing here. Whereas if we went with a smaller number, well, the streams are going to extend further up into the watershed. So from a practical standpoint, just calibrating it based off of the typical conditions in the area that you're working is the most appropriate. For me, well, this example is nowhere near where I live. Close to where I live, I'm finding that 7,500 is usually a pretty reasonable number. And then other areas, you can go lower or higher. Just depends on, I guess, the geomorphology of your area and the climate.
I'm just going to steal the screen back for a second here, which is because we're right at the end of our webinar time, and we're going to hang out and answer some more of these questions. But I did just want to share two announcements that answer a few of the questions that are here. So first off, version 11, as of today, really excited to share that even for regular RoadEng support customers, you can get access to the beta. So you can reach out to us, put a note in the question panel if you are interested in getting on board with it. You do have to be a client. That is part of our annual support program to get access. For non-clients, if you are curious in seeing what Path Explorer, for example, might look like on your project, yeah, we're happy to take your project files and give you a little tour of what it could do to it. And then the other piece, January 25th to 26th in Vancouver, we have our new version 11 training course. We're actually, almost sold out for the second session of it, 3 spots left, and it actually goes through all of these new tools. So that's in Vancouver. If you're interested, you could put a note in the chat as well. We're happy to answer that. So Matt, going back to questions, and I'll make you the presenter here again.
Okay.
Can you have multiple construction zones? For example, based on side slope requiring end haul.
So you can, yeah, you can have however many construction zones that you'd like. And the side slopes and end all, hopefully the previous answers for that kind of allude to how you can tackle that. Yeah, and not just, it doesn't have to just be polygons too. So the streams example, in all these examples, I've just used a blanket cost. Not all streams are equal. If you're putting a bridge in, you'll probably want a different cost for crossing areas where you're going to need a bridge versus areas where you can get by doing minor crossings and simple pipes. So yeah, it's all extendable and customizable to match what you'd like. One thing that I will say right off the bat, or I should have said right off the bat, but I'll say in after the fact now, is a rule of thumb for this stuff isn't to throw all the complexity that you can think of when you're solving the problem. You're just going to make more work for yourself. Leaving it unconstrained as much as possible is usually a great way to start. And then once you've run it, if you say, well, that doesn't look right, this should cost more, then look at chipping away and refining that to get your better solution. But yeah, it's like, aside from, I mean, the software will consider it. It's not a problem with that, but it's more from a keep yourself from going crazy. If you've got a project like this, and I went through and delineated every little aspect of the terrain, it's going to be more work than seeing where it puts it, and then kind of the, well, that's practical, and if it's not practical, refining the things that we missed to get the practical solution.
Okay, let's keep going. The list is huge.
Which is great. Nice to have questions.
Yeah, it is wonderful. And you know what, because of the newness of the features, yeah, happy to stay long. Would Path Explorer have chosen switchbacks if that had been required?
Yep. So I did notice that one come in when it came in, and the video that we looked at had a case where the original solution wasn't really much of a switchback. It popped up onto a ridge, and then once we constrained it, adding those slope stability concern areas that we had, then it was forced into a situation where the switchback option was the best solution. Unrelated to the question, one thing that I have found that I'm kind of surprised by running it myself, find designing switchbacks myself, I'm usually putting in something that's tight, close to the limits, and letting the optimizer run through it. It often lands on broader switchbacks, which are nice from a constructability standpoint, nice from a driver standpoint, and it's also reducing costs. So just an observation from someone that's played around with it as a designer too. It's pretty slick.
Okay. Hydrology tool question.
Okay.
Can you show the watershed boundaries?
I can.
And I guess a spoiler alert, you can do this in version 10 now. It's just not as awesome.
Yeah, it takes longer, and some approximations in there that we got rid of. So the watershed tool is it's going to delineate your watersheds relative to the surface extents, or if there's any major depressions, it'll delineate those interior areas. So I'll run this, and I have no idea what we've got for watersheds here. It looks interesting enough at a glance. So there we are. We can see we've got our main watershed, and then we've got these little sub basins going off to the side that aren't quite as large. So yes, that's the watershed tool. I suspect it's coming, but I will just mention it. We've got our drainage area to a point. So really useful feature. Unfortunately, I grabbed the build this morning, and we are tweaking that and making it even better. So I won't run it right now because it is actively being worked on, but that will, if we set our point there, it'll delineate the drainage area that contributes to that specific point. And we've got some other cool stuff in the works related to hydrology that we aren't ready to show yet, but it's still being built and improved upon, and yeah, it should be even better when we get to that final release.
Awesome. Let's keep talking about hydrology for a second. If someone has already calculated their hydrology in another software, can they load that in and leverage it in Path Explorer?
Yeah, totally. Doesn't have to be features that come from RoadEng. It's just a polyline. If you bring it in as a shape or a DXF or DWG or DGN, etc., it's still going to just be a terrain feature once it's in terrain, and you can apply whatever you'd like to it.
Okay. Talking a little bit more about Path Explorer and no-go polygons, would you use the no-go polygon to keep it from paralleling creek in a stream buffer?
I wouldn't use a no-go polygon because the no-go is absolute. So I would use a polygon with an increased cost if you were having a problem with that. So that'll let it cross the creek, but it'll deter it. Again, that is something that I think if you leave it unconstrained, it'll generally produce favorable results without even adding an extra riparian buffer in there. But yeah, and then the other thing you can do is it's really, of course, sometimes it makes sense to parallel those creeks as long as you build it right and have appropriate SOPs in place and all that stuff, so you can do the sensitivity test too to see, well, is it possible to do it somewhere else, and how much is that going to cost us to, if we want to do something that we're going to have to be extra careful along it.
Okay, the next question, and I'm going to tackle this one here. Would Path Explorer find the same paths if we were to restart it with the same settings? And really, as you saw, Matt was hitting a cancel button in there. So if you were happen to hit cancel at the exact same millisecond, it probably would find the same paths. Otherwise, there is probably going to be a slight difference, but very, very similar nonetheless. And this is because the paths are constantly updating. Now, Path Explorer does explore all possibilities, and if it returns a full solution early, it will definitely give you the same paths. But in most cases, the problems are so large that when you hit cancel, will have a ever so tiny, slight impact on the results you get. Which then brings us to the next question, which I think is a nice tie-in, and it says, does the Path Explorer file name contain projected cost?
So the file name, not exactly, but the feature name, which I suspect you're looking at, does. Now these costs are going to reflect these costs that we have assigned here. So just, the software is going to consider what it considers very thoroughly. But there's some stuff here that, like I said, we're using a simplified cross section. We're not accounting for the haul distance. So if you want a better cost estimate, I'd really lean towards using the location side of the software for that, so taking it out and doing that extra step. But if it's a matter of comparing apples to apples, we've got this one here is $504,000, and this one here is $507,000 based off just what the software is considering it in the Path Explorer.
Okay, let's do a couple more, and I think we'll try and wrap this up for 12 o'clock Pacific. Is this video going to be recorded and posted to our YouTube channel? The answer to that one, yes, absolutely, especially after we edit out a couple little blips at the beginning from me. So we'll be sure to share a link to all the attendees for that. And there was also a request for the topo surface. I'm not sure which one, but I'm sure we can include one of the topo surfaces. Perhaps if that question asker just wants to let us know which one they were interested in. Matt, the next question. Is there a way to find out the drainage function that can, sorry, I should simplify this one first. Can you find out the catchment area for a continuous man-made channel? Currently, it looks like you can only find out the catchment for one single point.
Oh, so when I said that I'm not going to run This right now, just because it is being worked on, that is one of the things that's being worked on. So it'll be a kind of drainage area to a feature, which yeah, will capture the contributing area to whatever features you want.
Okay. The next question is, will we be providing an updated tutorial PDF for version 11? Yes, absolutely. That's due out in February. Again, if you are on a beta, I'm sure we can give you a beta of our training tutorial PDF. Yeah, very, very exciting manual that just was done through a course a couple weeks back. Okay, let's see which questions we left unanswered. What types of file format options are available for import and export? Is it possible to maintain live data connections to other programs?
No, like even if we're using our live maps, the connection is static. So if we want to download our data from this area, it'll be downloaded and live in the train file. It won't be continuously linked to the web map tile service. But yeah, pretty straightforward to update as needed. Rationale behind that is well, record keeping side of things. We want to know what was designed or what we were considering when we designed it, and then if that live connection changes after the fact, we don't want that to mess up that record. And yeah, hopefully that answers your question.
Awesome. So guys, 12 o'clock Pacific, we're 15 minutes over. So we just want to thank you for attending our webinar. And if you've been with us throughout all of our webinars this year, thank you so much for being a part of them. Again, we love making webinars. We love creating new content, and our development team loves innovating new solutions. So we hope you enjoyed it all, and we want to wish you and yours a wonderful upcoming holiday season and a happy new year. Thanks, everybody.
Thanks, everyone.